There's this really cool notation that we use in higher level maths called fractional exponents. And you've hopefully seen it before, but if you haven't, we're going to catch you up right here and now. It's pretty straightforward. If you see anything raised to a power that looks like a fraction, that fraction is simply telling you two pieces of information. This denominator is actually what type of root it is, and this numerator of the fraction is actually what type of power it is. And so, this idea that 9 is raised to the 1/2 is actually just saying that you have 9 raised to a 1 power and taken to a second root, which looks like this. The square root, the denominator becomes the root, of 9 raised to the first power. Well, 9 raised to the first power is just 9, and the square root of 9 is just 3. So 9 raised to the 1/2 power is just a fancy way of asking, what is the square root of 9? And we know that. The square root of 9 is 3. It becomes a little trickier when you have situations like this. 8 raised to the 2/3 power, but not actually that much trickier, because 8 raised to the 2/3 power just means, remember, the denominator is the root, so this is a third root, or a cube root, of 8, and then the power is the numerator of 8 squared. Now, you can do this either way you want, but the other thing that's worth remembering is that you can write this as cube root of 8 squared, or as the cube root of 8 squared. That's the same thing, and I'm going to prove it to you. The 8 squared becomes 64, and the cube root of 64 will end up being 4. 4 times 4 is 16, times another 4 is 64. So the cube root of 64 is 4. But on this other side, we've also decided that this could be the same as the cube root of 8 all squared. Well, the cube root of 8 is 2, because 2 times 2 is 4, times another 2 is 8. So, and then 2 squared, well, that's just 4. So it doesn't matter which one you use. I find that I personally end up liking taking the root first, because often that means that my math is a lot simpler. When I do the root second, sometimes I have a big number as an intermediate step, and I don't like that as much. Either way works, though, and they're both mathematically sound.